Hello there, ninth graders. This is Mr. Kashi speaking. Obviously, I can't be there today. We're going to go through the lesson through this video. So hopefully you've gotten your note sheet here and we're able to get started here. If attendance hasn't been taken, if we could go ahead and do that while we go here, that's fine. And then we're going to take some 8-6 notes, and you'll have plenty of work time to work on the worksheet or the IXL assignment. So this is our objective for the day. By the end of the class, you'll be able to find the common ratio of a geometric sequence and use the geometric sequence formula to find any term in a sequence. So that is quite a bit. We're going to go through each one of those. So the first one is we just want to talk about this intro example here. Okay, so it is 8-6 on geometric sequences. If you get stuck, you can look in your textbook on page 460. Hopefully that should have a few answers for you. And the intro example. So we have this key point, intro example, and then this sequence right here. So we have 2, 4, 8, 16, and hopefully just pick up on the pattern here. So 2, 4, 8, 16. The next one would be 32. Next one would be 64. Last one would be 128. Okay. Now the question is, how do you know those next three? What was the pattern that you had to pick up on in order to find those next three? And hopefully you know that we multiplied 2 by 2 to get to 4, and then we multiplied by 2 again, and that's what we keep doing, is multiply by 2, multiply by 2. And that is from our daily objective there, that is what we call a common ratio. Okay, what number are we multiplying by each time to get the next number? That is what we call a common ratio. In this case, it's multiplying by 2. And we're going to go through multiple different examples that it's obviously not just going to always be multiplying by 2, but multiplying by different numbers. That common ratio can be a fraction, it could be a decimal, or it could be negative as well. So, a geometric sequence. Let's go through what a geometric sequence looks like. So that one was just the numbers. Here we have basically n, and we have our terms are numbered. Okay, so if n was 1, 2, 3, or 4, and our terms here would be something like the first term would be 3, and the second term would be 12, and the third term would be 48. Okay, and here you can pick up the pattern just if you're given 3 numbers. Because here what we have to multiply is we have to multiply by 4 to get to 12. We got to multiply by 4 to get to 48. And so that's our common ratio. And so if we take 48 and multiply that by 4, hopefully you have a calculator handy. Some of you might be able to do that in your head. We would say, well, we got to multiply by 4 again, and we get 192 in that case. Obviously something that you could do, you could just do 12 divided by 3 and get 4 that way. And also do 48 divided by 4 and get 12 to get to just that number before it. And you can kind of pick up on that pattern. Obviously, by now you should know that the opposite of multiplication is division. And so 12 divided by 3 gets you 4. And 48 divided by 4 gives you 12 as well. Okay, so just getting that number right before it. Some other examples here. We'll do this as a practice, but we'll kind of walk through this one. Even if our numbers are negative. So our first term would be a negative 2, and our next term would be a negative 6. And our last term, or our third term here would be negative 18. So even though that our terms are negative, a negative 6 divided by a negative 12, that would be a positive 3. So from going from 1 here, we're still multiplying by 3 even though our terms are negative. And then negative 6 times 3, that would be a negative 18. And then to go the next step further to find the fourth one, you would then take negative 18 times 3 and get negative 54. Okay, so the common ratio here would be 3. Even though that those terms are negative. Okay, if you need to go ahead and stop the video if you need to at any time to record more notes. Okay, so we're going to go through another example. the table here. The first three terms are 64, 32, and 16. This is one that I have to remind students that we're always multiplying here. So even though we're going down, we don't divide. I get a lot of people that think that the common ratio in this case is dividing by 2, when it really isn't. We have to multiply every time in a geometric sequence, and so we're actually multiplying by 0.5 or 1/2. So here we're multiplying by 1/2 or 0.5, because half of 64 is 32, half of 32 is 16, so we're multiplying by 0.5, and then if we multiply by 0.5 again, we would get 8. Okay, so our common ratio here isn't a whole number, it's actually a fraction or a decimal, whichever you prefer, 1/2 or 0.5. And notice how we're decreasing in that case. Decreasing by a factor of 0.5 from one term to the next. Okay, pause it if you need to, but we're going to move on to that next example here. We have first term is 3, next term is -15, and the last term is 75. Okay, and then obviously, sometimes I ask, okay, well, what's the common ratio? Or sometimes I'll ask, what's the fourth term? When really, you wouldn't be able to find that fourth term without finding the common ratio. You'd have to pick up on that pattern and know what the common ratio is to find that fourth term. So here we're alternating. We go from a positive to a negative back to a positive. And if you can remember, obviously the simple arithmetic rule of a negative times a negative is a positive, then that's how we get this alternating effect. So if we take 3, what do we have to multiply 3 by to get to -15? Hopefully you know that's multiplying by a -5. 3 times -5 gives us -15. And if you take -15 and multiply it by a -5 as well, you're going to get a positive 75. So the common ratio here would be -5. And then if you were to multiply by a negative again, multiply by a -5, we would go back to a negative, and that would actually be a -375. So in this case, the common ratio is a negative number, and that causes our terms to alternate going from positive to negative and then back to positive again. So one thing that I want to add to your sheet, one thing that just the reasoning for what we're going to be doing next is if we had a little table here, we had n, and we had the term, we just went 1, 2, 3, okay? And I said we had something like this. We had 2, and then we had 4, and we had 6, okay? And then instead of asking what the fourth term was, what if I wanted the 50th term? Okay, so now obviously this is something that you don't want to, sorry, this should be 8, not 6. Okay, this is not something that you want to do 50 times. You don't want to go 2 times 2 times 2 times 2 and keep going and keep going. There's got to be an easier way. Okay, and that's kind of the point of today's lesson. So if you move on to your next slide on your notes, we talk about a geometric sequence and just the formula that goes with it. So this is the general formula that we use, and this is in function notation. So we say a of n equals a times r to the n minus 1. Okay, and we'll explain exactly what all of these mean. Okay, and we're going to start with this a of n. So when we find, this is going to basically be our answer. This is what we call the nth term. Okay, and so when I said, okay, well, what's the 50th term? Well, you would find out that, and that would be our answer. Usually we find the nth term. The a right here, this is always going to be our first term. And the r is, I'm guessing some of you have figured that out, is the common ratio. So the R stands for ratio. Okay, and then last is the exponent here. That n right there has to be the term number. Okay, and we take 1 off because it's counting the number of times those numbers get paired up, not the number of terms. And so we just take whatever our term number is, subtract 1, and that becomes our exponent. So to use our formula here, it says find the first, fifth, and 10th term of the sequence. We have a of n equals 5 times negative 2 to the n minus 1. And they are asking us to find the first and the fifth and the 10th. So how to answer this problem is I would have an n, I would have a term, and instead of going 1, 2, 3, 4, 5, 6, I would just say 1, 5, and 10. Those are the ones that we have to find. Well, finding the first term is a little silly because we have this 5 right here. That is just like the slide or the key point ahead of this. That is the first term, so it tells us right in the formula. Okay. Now to find the fifth and the 10th term, that's a little different. Okay. So to find the fifth term, how we write it was we'd be saying a of 5, which basically is just function notation of saying, okay, I'm going to find the fifth term. And then you do 5 times negative 2 to the 5 minus 1. Okay. And so what we have is negative 2, 5 minus 1 is 4. Well, negative 2 to the 4th, that's a positive 16. So then what we would have here is we'd have 5 times 16, and you can either do that in your head or use a calculator. So that would mean that a to the 5th would be an answer of 80. So 5 times 10 is 50, 5 times 6 is 30, 50 plus 30 is 80. So here you'd come up and you'd put an 80. Okay? And if you wanted to find a of 10, you would say, okay, well, we have 5, negative 2, to the 10 minus 1 in the exponent. So just rewriting here, we would have negative 2 to the 9th. Some of you might be able to skip that step, but be careful when you do. And then 2 to the 9th is obviously a tricky one that you would want to use your calculator for. And a negative 2 to the 9th means that we're going to have a negative answer. And that would actually be 5 times, and this would be a negative 512. And so then when you multiply that by 5 again, you're going to get a rather small answer, obviously, since it's being negative. And when we do that, we get negative 2,560. So this is negative 2,560. So you have those three terms. You found the first, the fifth, and the 10th. The first was easy to find because it was right in our formula. Okay. This is one that I'd like you to try in class. Okay, take that formula and I want you to find the first, the fourth, and the 7th terms of that sequence. Okay, there will be an answer key left for the sub for you guys to go over this one in class, but I will obviously be here next time to field any questions that you may have on this concept.